All right, we finished the last video talking about a few scientists and what they contributed to the atomic theory, and we're going to continue looking at some scientists in this video as well. The next one that we're going to look at, his name was Niels Bohr, and in Bohr's model he added energy levels, and energy levels are just possible energies where an electron might be able to be found. Electrons can have more or less energy than each other. They're not all equal, and it really depends on how far away they are from the nucleus, the center of the atom. The closer they are, the less energy they have, and the further away they are, the more energy they have. So he said that electrons cannot exist between energy levels, and he also said that electrons in an atom can move from one energy level to the other. If they gain energy, they can move to a further away energy level, and if they would lose energy, they can drop back down closer to the nucleus. So this would be Bohr's model. Normally you would see this with at least two energy levels drawn, and normally a little bit more circular than what I just attempted to do. Right here in the nucleus, this would be your center. Okay, that's your dense, heavy center. And then these would be electrons here on the outside. And these electrons, he said, travel in a ring around and around and around the nucleus. And so you would have electrons here on the outside ring as well. So he said you can't have any here. So there's none that exist in between. They have to exist on the energy level themselves. And he did say that if this electron were to gain energy, it could move and it could be placed out here on an energy level that has that is further away. So these have more energy. More the further away you are, less energy the closer you are. And if it would lose energy, then it would drop back down and it could drop to a lower energy level. Now, moving on to our modern view, a lot of the times Schrodinger, you might have heard the name Schrodinger before. This would be our modern view, the one that we currently hold to for our atomic theory. Bohr was kind of onto something, but we tweaked it a little bit. So the nucleus contains protons and neutrons and neutrons are heavier than electrons. So the nucleus is heavier, it is denser, and this makes up the mass of your atom. So mass is equal to protons plus neutrons that are both in the nucleus. The nucleus is going to have a positive charge to it. And instead of having energy levels, because in energy levels, remember he said that this electron just has to keep traveling and around and around and around in a circle, and it can move from circle to circle, but it can't go anywhere else. Now we have this idea of an electron cloud, and this is just, we have to actually use very technical math and probability to find these electron clouds and where you might find an electron. But if this is your nucleus in the center, a lot of the times you'll see dots. And the closer the dots are, the higher chance you have of finding electrons. So since the lower energy gets filled up first, you're going to see in some pictures this electron cloud picture is really lots and lots of dots. So it looks really dark. And then the dots kind of get further spread apart, not as thick. And so your chances of finding an electron here are pretty high because the picture shows that the electrons, the chance is a lot closer. Less of a chance of finding an electron out here just because of the way the picture is shown. So that's what the electron cloud model looks like. It doesn't have these set energy rings like Bohr's model did. Most of the volume of your atom comes from the electron cloud. So the mass comes from the nucleus in the center, but most of the space actually comes from all of this empty space. That's where your volume comes from. The cloud is denser, again, where you have a higher chance of finding an electrons, like I showed in the previous picture. We also have some other terms that you might hear pop up. Orbitals are just regions of space around the nucleus where you're likely to find an electron. So the cloud, again, closest to the nucleus, that area that was more dense, that would be one that would be more likely to find an electron. And the orbitals closest to the nucleus have the least amount of energy, and I mentioned that previously as well. So that kind of holds up with what Niels Bohr had mentioned with the energies being able to gain energy, you move further away from the nucleus. So that still holds true. A configuration is just the arrangement of electrons, and this is something that we'll practice together in class, and being able to know how many electrons might fit in a particular energy level, because they don't all contain the same amount. But the most stable configuration is one where you put your electrons in the lowest energy. So even though they might be able to jump up to a higher energy level, you would want them to be in the lowest energy first. Some definitions: ground state is when the electrons are going to be in their lowest energy level. So again, if you have 2 electrons, you would want to put your electrons around the nucleus in the first level first, and that would be ground state when they're in their lowest possible energy level first. And excited state is when the electrons have been able to absorb some energy. They can get energy through electricity or through heat. So if we take these electrons that were here and we give them some energy, they can actually bump up into a higher energy level, which isn't where they would normally go. And so we would call that an excited state when they're in a higher energy level than they should be in. The higher energy is less stable. So normally they don't stay there for very long. As soon as they lose that energy, maybe they get too far away from the heat source, so they start to cool back down, then they may drop to the lower energy again. When electrons lose energy, this is when we can see all sorts of really neat things. We see this loss of energy. They show this by neon lights. Fireworks work this way. They get heated up, and so the electrons start moving quickly. They get further away from the nucleus because they're gaining energy. But when they lose that energy and they drop back to the nucleus, they give off all sorts of different colored lights, and different metals give off different colors. And that's how they choose what type of metal they need to put in a certain firework based off of the type of light that particular metal gives off when it loses energy. And that'll be the end of video 2. In your next one, we'll take a look specifically at protons, neutrons, and electrons. And we will start to give some definitions and look at the periodic table so we can learn how to calculate how many protons, neutrons, and electrons are in different atoms.